Welcome back. In the previous session, we have discussed about the different functional groups which make up different types of carbon compounds. Till here, we have discussed only about hydrocarbons which are having straight chains. It could be alkane, alkene, alkyne, or alkanes containing different functional groups. We know that carbon compounds can exist as the hydrocarbons or carbon compounds. They can exist as either straight chains, which we have discussed till now, or they can also exist as branched structures or as cyclical or ringed structures. So in this particular video we will be discussing about the branched and cyclical structures of different carbon compounds. Let us begin with branched structures of carbon compounds. To understand this, let us take butane as an example. So, butane, it is an alkane which contains but, meaning 4 carbons. So, the formula of butane will be C4H10, because alkane general formula is CnH2n plus 2. This is the molecular formula of butane. The structural formula of butane would be, we have to write down the 4 carbons, join them using single bonds and fill the valencies of carbon using hydrogen atoms. So this would be our normal butane. Now we can also write or represent C4H10 using another structure. How? So C4H10 could also be represented as 3 carbons in a straight chain and the 4th carbon attached to the middle carbon. So by doing so, what would happen is we would get a different structure for C4H10. If you compare these two, what is similar is both of them have same molecular formula but different structural formula, different structures. Such carbon compounds are called as structural isomers. So what we are seeing here are 2 isomers of butane. So this is named as N-butane. N refers to normal butane, whereas what would be the name of this structure? So this would be named as 1, 2, 3. The CH3 group, it is called as a methyl group, because CH4 is methane. If you remove one hydrogen from methane, it becomes methyl. So this CH3 group is called as a methyl group, which is the functional group here. So the name of this structure would be 1, 2, 3. That is 3 carbon is and all single bonds are present. Propane, the functional group is attached to the second carbon, so it is called as, functional group is methyl, so methyl propane. Because it is attached to the second carbon, it is called as 2-methyl propane. That would be the name of this structure. And both these are structural isomers. They have same molecular formula but different structural formulas. You can check whether they have the same molecular formula or not. 1, 2, 3, 4. 4 carbon and hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, carbon compounds which have same molecular formula but different structures are called as structural isomers. Similarly, we can write the structural isomers for pentane. Let us do that. Pentane has the molecular formula C5H12. So, one of the structures would be the normal pentane. So, we have to write 5 carbon compounds in a straight chain and add the hydrogens. So, this would be the normal pentane called as N-pentane. Count the number of hydrogen atoms and also check the valency of carbon always to make sure that the structure is right. This is one structure we can write for pentane. Another structure we can write for pentane would be to remove one carbon from the main straight chain and attach this carbon to the middle of the chain. So that is how we write the isomers. Remove one carbon and attach to the middle of the chain. We cannot attach the carbon once again to the last carbon because then the structure would be exactly same. So remove a carbon and attach it to the middle of the chain. When we remove the carbon is associated with the methyl group. So minus CH3 group. So remove a CH3 group. When you remove the CH3 group, as you can see, the main chain will have 4 carbons. So 1, 2, 3, 4. This is what we did in butane also. Remove one carbon. So CH3 group, we have to attach this CH3 group where we cannot attach it either to the first carbon or to the last carbon. Then it would be exactly same. So we have to add it either here or here. Both would be exactly the same because if you number it from here, it would be 1, 2, 3, 4. If you number it from here, it would be 1, 2, 3, 4. So it doesn't really make a difference. So I am adding this CH3 group here, CH3, and add up the valencies by adding hydrogen. This would be the isomer, possible isomer for pentane. What would be the name? The name of this structure would be, first count how many carbon atoms are there in the main chain. This is the main straight chain. The longest carbon chain, how many atoms does it have? 4. So the name would be butane because the longest carbon chain has 4 carbon. Then identify the functional group. The functional group is CH3. This CH3 is attached to the second carbon. So CH3 is methyl. The name would be methyl butane. The methyl group is attached to the second carbon. So the name would be 2-methyl butane. There is one more isomer possible for this. That would be, once again, remove another CH3 group. So the main chain will have So if you remove again one CH3 group from here, the main carbon chain will have 3 carbon atoms, and the CH3 groups, you know, we cannot add it to the first carbon or second carbon. It has to be added to the middle carbon. So we can add it like this, and finally fill up the valencies by adding hydrogen. So this is another possible structural isomer of pentane. Butane has 2 isomers possible, whereas pentane has 3 possible isomers. What would be the name of this structure? Once again, set the main chain. Main chain has 3 carbon atoms, so the name would be propane. Now in this case, to the second carbon, this is the second carbon atom, it is attached to 2 methyl groups. So it would be dimethyl propane. So the A's and E's should be written very clearly. Dimethyl propane. And to which carbon are these methyl groups attached? Both the methyl groups are attached to the same second carbon. So we can write it as 2,2 dimethyl propane, indicating that both the functional groups are attached to the same carbon. 2,2 dimethyl propane would be the name of the third structural isomer of pentane. Similarly, as a homework, you can try writing the different structural isomers of hexane. Formula is C6H14. How many structures are possible? Write their structural formula and try naming the structures. So this is all about branched carbon compounds. So they have branches resulting in structural isomers. Finally, let us take a quick look at the cyclical carbon compounds having a ringed close structure. For understanding cyclical carbon compounds, let us take the example of hexane itself. So hexane is C6H14. So this is a straight chain carbon compound where all the 6 carbons are present in a straight chain. Now if you were to make it into a cyclical ring-like structures, what would the structure look like? The cyclical structure would have a hexagonal shape where each edge or vertex of the hexagon, it would have 1 carbon atom like this. So the structure would be a hexagonal structure. So the 6 carbon atoms are joined in the form of a ring. And what about the valencies? So let us start from here. This carbon is attached to 2 more carbon atoms. It requires 2 more valencies to be filled, which can be satisfied with the help of hydrogen. Similarly, we can do this for all the carbon atoms. The structure so resulting so we have 6 carbon and we have their valencies satisfied. This structure is called as a cyclohexane because 6 carbon atoms are present in a cyclical manner. What would be the formula of cyclohexane? So when the straight chain is converted into a ring-like structure, you would see that the formula of cyclohexane would be 2, 4, 6, 8, 10, 12. So compare this with a normal straight chain hexane, it would have 2n plus 2, whereas cyclohexane is C6H12. It has got all single bonds, so cyclohexane is saturated carbon compound which is cyclical. Similarly, we can also have unsaturated carbon compounds in the form of a cyclical structure. So let us write for unsaturated using the same hexane. Only thing is that for unsaturated there should be a double bond. So let us write the structure. Once again, draw a hexagon and the edge, these points, vertex, will be replaced by carbon atoms. Now, because we are drawing a unsaturated cyclical hydrocarbon, for it to be unsaturated, it needs to have at least one double bond. Only then it could be called unsaturated. So either double bond or triple bond, and it's right for double bond. So I am going to put a double bond between these two carbon. So now it makes it unsaturated. And finally, let us check the valencies of carbon and add hydrogens accordingly. So in this case, we see that this carbon, it is attached to 1, 2, 3. It needs one more hydrogen. So I put one hydrogen. Take this carbon, it is also attached to 1, 2, 3. It needs one more hydrogen. This carbon is attached to two more hydrogens, similarly like this. Now, what compound we are writing is called as a benzene. A benzene has got three double bonds. Ene, so it is an alkene, unsaturated. It has got three double bonds. The double bonds are present at alternative bonds. So if there is one double bond over here, leave a gap, put another double bond here, leave a gap, put another double bond here. So that is the structure of benzene. Finally, add the hydrogens. So this carbon will require one hydrogen, this will require one hydrogen, this needs one hydrogen, and this also will require one hydrogen. So the formula for benzene is C6H6. 6 carbon attached to 1 hydrogen each. The valency 4 is fulfilled everywhere. So these are two examples for cyclical carbon compounds. So cyclohexane has C6H12, whereas benzene, which is unsaturated, it contains 3 double bonds. 1, 2, 3. We can also put the double bond at alternative places. We can put the double bond here, then leave one bond, put it here, leave one bond, put it here. We cannot put two bonds together because then valency of carbon will not be satisfied. That is why at alternative bonds we have, or at alternative carbon atom we have a double bond. So this is another possible structure for benzene. So that is about ringed structures. So it could be straight chain carbon compounds, it could be cyclical carbon compounds. They could be either saturated or they could be present as unsaturated compounds. So that is all about the different types of alkanes, alkenes and alkynes present as straight chain, as branched structural isomers, as well as present as ring like structures. Thank you.